Okay, she's in the library. This is the real number system intermediate video. So let's see what kind of questions we have here. It says, which classifications of the real number system describe all numbers in this set? So we're going to have to check and see what types of numbers we have here. So let's start with real. All of these numbers are definitely real, so we know that we have those set. Rational, that's a decimal that stops. That's -17. Let's put in, if it can be written as a fraction, then it is definitely rational. So 2/3 is rational. 4 1/8, again, if there is a fraction, it is rational. And 9 squared is 81. So they're all real and they are all rational. So we know they are not irrational, so we're going to mark that out. Are they all integers? Integers are your perfect number line numbers. We have decimals, so that means they cannot all be integers. And if they can't be integers, then they cannot be whole numbers. And if they can't be whole numbers, then they can't be natural numbers. So real and rational are your only two answers here. All right, it says identify which statement is false. That means which statement are you answering no to? Okay, so let's read the first one. The product of two rational numbers is rational. Let's go ahead and just put something in. 2 times 2 is 4, so that is definitely true. So the answer there is yes, which means it's not the one we're looking for. The next one says the sum of a rational number and an irrational number is irrational. So 2 plus pi is definitely irrational, so that one is also true. You got to remember that when you put an irrational number anywhere near anything else, then you know it's definitely going to be irrational. Then number C says the sum of a rational number and an irrational number is rational. Well, we just did that. So the sum of a rational number and an irrational number is irrational. So this answer is no. So that's going to be our answer. And then the product, so we're going to go ahead and try that. The product of a non-zero rational number and an irrational number, we'll use pi again, is irrational. And that is true. Again, that's a yes. So C is our only possible answer for that one. If you don't know the answer, use calculator, figure it out. All right, here we go. This diagram represents the relationship between two sets of real number systems. Which classification of the real number could A and B represent? So it's saying all natural numbers, A, include integers. That is not true. I'm actually going to write my chart out so that way I know what order it goes in. Rational, integer, whole, natural, and I know irrational is over here by itself. So it's saying that if you're a natural number, you include integers. That's not true. If you're an integer, you include natural numbers. So A is out. The next one says rational numbers includes irrational numbers. That is not true. They are separated. The next one says rational numbers. If it's a rational number, it includes real numbers. Well, real is actually the title at the top, so that doesn't look right. And then integers include whole numbers. That is true. Integers do include whole numbers, so your answer there would be E. So let's go over and try to record the next one. It says, which of the following can be defined as an integer but not a whole number? So first thing we're going to do is come through here and look at it. Negative 13.1 is definitely not an integer, so we can get rid of that. Negative 20 divided by 5 is negative 4. That is an integer, but it is not a whole number. So this very well may be our answer. Then we have negative square root of 20, which we know is irrational, so it's definitely not an integer. And negative 1/3 is a decimal, so it's definitely not an integer. So the only one that works there is C. And now we're going to go to real number advanced on our next recording.